So following on from the previous video, we've got this situation here where we've got this car here moving horizontally along here, and then we've got a police car here 40 meters perpendicular to the road here. The police car then fires the radar gun at the moving car, and then the radar gun tells the police car that this car is moving 30 meters per second in the diagonal direction. Okay, the car is actually moving along here. What we want to know is this speed here, not this speed here. Well, the radar gun is telling us it's going at 30 meters per second in the diagonal direction. So let's try and solve this. The question is how fast is the car going in this direction? In this direction here. So how fast is the car moving in the horizontal direction? This speed here is in the diagonal direction. Okay, so let's set up a model here. So let's call this let's call this x. Okay, and then let's call this distance here capital D. Okay, so hang on. So now we've got so this is our car. This is our car at the moment. So if you think about it, hang on. Let's look at this here. So you've got x here. So x squared plus 40 squared, that would give you d squared here. So this is the relationship that ties everything together. So by using Pythagoras, we've got this thing here that ties everything together. Now d by dt, well, we said it's moving 30 meters per second, but the thing is, it's actually we've got to stick a negative in front of the 30, because if you think about it, so this is like your graph here. This is 0, 0 here, and then if x increases, then d gets bigger and bigger. Okay, so if you increase this dot here, if you increase x here, d will get bigger and bigger. D will be positive and positive, positive. D will get bigger and bigger as you increase x. Now the car is moving in this direction here, so x will decrease. Now as x decreases, then the diagonal here will also decrease. Okay, let's look at this. Currently x is here. If you increase x, then capital D will get bigger and bigger. If you decrease x, then capital D will get, the diagonal here will get smaller and smaller and smaller. Here we've got a situation where the diagonal here will get smaller and smaller and smaller. So because we set up this system here in such a way that it's like our graph here, 0, 0 here. As you increase x, capital D will increase. But then if you decrease x here, capital D will get smaller and smaller. So we've got a situation here where the car, well, d by dt will be negative 30 meters per second, because the diagonal line is decreasing as time goes on. Well, anyway, using Pythagoras, it would give us this. Now let's think about this situation here. We want to write everything relative to time because the car is moving. So hang on. So as the car is moving over time, x is a function of t. So you can think of x. This distance here, x, will be a function of t. So as time moves on, x changes. Now as time moves on, capital D will also change. So we can say that capital D is a function of time. Okay, and then so here as time moves on, this 40 doesn't change. Let's say after t equals 3, after 3 seconds, the police car will always be 40 meters away from the road. As when t equals 5, let's say, the distance between the police and the road is still 40. 40 doesn't change. 40 is a constant. The thing is, x is a function of time. Capital D is also a function of time. So when you come to differentiate this, you have to, well, let's differentiate that now. So let's differentiate this with respect to time. So it will be 2x, and because x is a function of time, we've got to stick dx by dt here. Okay, and then this is just a constant, so that's going to go to 0. And then this one here, it will be 2 capital D, but then because capital D is a function of time, it will be you've got to stick d by dt. Okay, so when you come to differentiate this here, it will give you this. Okay, so hang on. So currently Pythagoras is the thing that ties everything together. Differentiator, it will then give you, hang on, bear with me. It will then give you, oh, hang on, bear with me. Hang on, bear with me. Oh, okay, hang on. Differentiate this, it will give you 2x. Well, I will continue in the next video. Okay.